RFID has been gaining traction across a wide variety of sectors. Manufacturing has always been the largest segment of our database, and so we have the most readers in manufacturing. And RFID is being used across a wide variety of different applications in manufacturing. And I'd like to introduce now our first speaker, who is Ed Dobrotsky, and he's going to be talking about utilizing IoT technologies to improve workflows. So Ed, just give me a second and I will give you control of the mouse and keyboard.
All right. Thank you, Mark.
Okay, you should be good to go.
All right. Thank you very much, Mark, for the introduction. We're excited to be part of this webinar to talk about manufacturing. It's a topic that's near and dear to our heart. Omni-ID, since we pioneered the first on-metal labels, has been very focused on the manufacturing sector. And some of our physicists and our scientists that work on some of the toughest problems in our company spend time working on industrial environments and factories specifically, where we have a lot of metal and difficult conditions. So we're pleased to talk about this today and to talk about what people are doing. We'll discuss some of the core issues facing asset and material management in manufacturing that we see today from our perspective. And we'll also highlight today some of the applications that are currently being deployed by our customers and by others that we're working with in the marketplace to solve the problems. To start with, as you see on the graphic, containers and looking at the movement of containers is one way to measure material flow. And today we see dramatic increases over the last few decades that have been building and continue to build in the flow of these containers. Today, hundreds of millions of returnable containers are cycling daily around the globe. You may not even think about them, but when you think about all the different goods being manufactured, whether by ship, by rail, by truck, these containers cycle back and forth through supply chains and through factories continuously. I would think many people on this call that are in their manufacturing capacity can do a silent count in their head about how many containers their operation owns, or that they service, or if they're a vendor, how often they're filling containers, putting items in. Containers really are the central piece of material flow. In the 90s, offshoring the supply chain was a big factor in increasing container traffic dramatically worldwide. That's continued to build into today's current trend, where we see the concept of nearshoring happening now. As costs in China increase and delivery costs increase, we're seeing now more traffic in closer countries like Mexico and Canada coming to the U.S. market specifically, but also in our other markets where they have neighboring countries they're using for land-based logistics and thus developing manufacturing. Through both trends, container traffic has continued to grow dramatically and continues to be the key to the material flow. But there's other changes happening. We're not going to spend a lot of time today talking about logistics, because although logistics is a key part feeding manufacturing, and the movement of those containers is key from that perspective, the real issues that we're here to talk about are right on the plant floor and within the manufacturing world, once those containers arrive. It used to be in the 70s that mass production and serial production was the real key. We tried to improve quality and go lean by simplifying our processes and making them very, very direct and simple, a lot of serial production. But today, the world has changed, and today's manufacturers are facing a very complex set of demands. They want real-time production of real-world demand coming from the internet, coming from informed users on smart devices, and thus their process is very complex, often asynchronous, often with a lot of small pieces that are destined for different parts of the production. And so the process we've used since the 70s really can't keep up anymore, specifically some of the paper labeling, paper Kanban cards, and the lack of traceability and tracking really can't sustain what needs to happen on the plant floor today. We'll explain a little bit more of what exactly we mean by that. But I think anyone on this call who's living a current manufacturing life recognizes what's happened since the 70s to now and the complexity of their job, how it's changed so dramatically over these last couple of decades. And unfortunately, I'm here to tell you it's only going to get worse as IoT technologies come in and more is demanded out of the plant floor. So our focus here inside the factory rather than supply chain makes us think a lot about this problem. You know, from the shipping dock, from the parts warehouse to the shipping dock, you know, there's this cloud in the middle, this black hole, where perhaps our old processors were pretty much tribal knowledge. A worksheet was printed out, a job ticket was printed out, and the workers on your line kind of knew how to stick handle that job through the process and get all the steps done and get it on the back shipping door. they might have been guided by a paper label that was very static. But the real-time visibility and control using that method is very poor. And if you want to live in a world such as Amazon is pioneering, where real-time demand triggers can come instantly and repicks and changes can happen on the fly, those old paper-based systems and lack of traceability really can't help you be the flexible factory that's being demanded today. So new processes are required. And we can talk about some of those processes and how they work as you go through a very complex flow within your factories. So I want to introduce you to two paradigms that we talk about at Omni-ID. And I think they're truisms that many of you are living, but they're certainly watchwords for us as we look at it. For asset tracking and for visibility, one reason you're going to think about putting some kind of RFID system into your plant is that you want to start to have visibility into what's happening. You want to see what's on your plant floor. And there's a truism here that you can't manage things you don't track. Why do you see where it is on the plant floor? Often this is just about what inventory do I have? How much of it do I have? Where exactly is it? So that I can figure out, do I have enough for the next day's production? Can I make the 4 o'clock truck with that job? One reason to introduce RFID is to be able to track actively your assets so you can manage your process better. But the second paradigm we talk about at Omni-ID that maybe you haven't thought about as much is that if you want to control the process, in other words, change its outcome dynamically, react to demand triggers quicker, even demand triggers that might happen partway through your process to redisposition a part to a different place, you need to be able to communicate. RFID is great for tracking. You can pick up that unique ID, that license plate that's on your asset, and know exactly what is where and create accurate counts of exactly what's in your system. But it's not necessarily a good medium to communicate with your workers and to tell them what to do differently or to navigate your parts through your process in an effective manner. For that, you need a communications medium, a feedback loop that comes from this tracking that's going on. So we operate under both paradigms, and I think it's important for everyone to consider both paradigms. If you're interested just in tracking, RFID is a great solution. If you're interested in managing or controlling your process in real time, instantly acting on the information that comes from an RFID, you have to expand your system a little bit, picking up those RFID tags and doing something different in your control layer. And we'll talk about that in a little more detail. In fact, on the next slide, we talk about our product answers to this. We have a wide set of RFID tags that we sell into many different applications for tracking. And by far, it's the most common thing that we do, just tracking assets, and we understand very well that use case. If you ever had any doubts about is there a tag that can do this? This might be survive high heat, or this might be store a lot of things with a big memory set, or can it survive an on-metal application and still be able to function? Can I get X distance out of it? You should know that RFID has matured a lot since perhaps you last looked at it, and there's hundreds and hundreds of tags of many different characteristics, virtually to tag almost anything that you could possibly think of tagging for any condition. UHF is a mature technology built on an open standard, and on-metal and rugged environment RFID specifically has grown leaps and bounds over the last couple of decades, and you can probably find a tag to do what you need to do on the tracking side. On the control side, there are starting to become some new solutions from this IoT side of the world where you're getting real-time feedback coming through the tags and through the tagging systems. We see this in Europe with our Industry 4.0 initiatives, and certainly see it here in the Americas through some very innovative e-paper and visual tagging systems that we're doing in the IoT world here. So our ProVIEW solution set is really focused on that particular paradigm of real-time feedback to control your material flow. So if you're facing this decision, what do I do to improve my manufacturing plant floor? You've got a few different options. There's manual labor. We find as we do audits and as we walk into different customers, still by far the majority of our marketplace is tracking by hand. That means you've got material operators or you've got planners going onto the production floor doing hand counts, doing tallies for the day, doing production planning. Sometimes it's something simple as a paper and clipboard or a spreadsheet. That's a viable option. You can do it that way. The challenge is it can be very expensive to have those people working to do that, and it can be less reliable, as unfortunately as humans we all make mistakes, and it's prone, that system, to errors that can be very costly for you in your delivery reliability. We certainly have a number of people that have utilized barcodes and you can certainly track by scan. It's very reliable. It certainly gives you, a better accuracy than a manual count. The challenge, of course, is that line of sight problem, and we find this a lot when you're trying to count things that are stacked up in storage areas or even in work in process collection areas. It's difficult to go and do an accurate count. So we find that people in those cases are going to do the manual count really and approximate it with a couple of scans. Certainly at certain choke points, a track by scan is possible with that line of sight, and that can even be automated with the scanner. You also face in some conditions that can easily be degraded in the factory. The conditions that we all work in can either scuff or mar or obliterate that barcode very easily. Hence the popularity for RFID, the fact that you don't need the line of sight, that it's not easily degraded, and that you can take multiple inventories even without being able to see the goods. By hanging an antenna over an area, you can see what's in an area very quickly and very automatically. It's a very good solution for asset tracking options on the plant floor, probably one of the best solutions as you understand it and get a good partner to integrate and put it into place. So I promised I'd share with you some applications rather than just talk abstractly about the concepts. What are people doing today? So this is an example of a high memory tag and what it's doing in the plant floor. So a typical RFID tag might have a very, very small memory space counted in bits, maybe 96 or 128 bits. There might be some extended user memory of a few hundred more bits, maybe up to 512. There are operations on the plant floor where you want to store production data on the tag. And some of my friends in the consumer world say, well, why would you ever want to do that? Why wouldn't you use the cloud and store everything up in the database and just use the tag as a license plate? That's certainly viable and happens a lot in other markets especially. But on the plant floor, for real-time control, there's a reliability factor that our automation engineers love about storing the information directly on the tag. This puts the PLC in control versus an upstairs network or an outside network, which they might not want to rely on the same way. We certainly also see the political divisions between plant floor IT and plant floor automation groups, and there's reasons why the automation group wants to keep control over this key production data and time stamping within the PLC cycles rather than up in the higher-end network. So for this reason, we have a lot of applications for high memory RFID where opcodes and production information can be stored directly on the asset as it travels through the production. At the end of the process, those opcodes and timestamps can be uploaded so that they can be in the cloud database. But during production, they can be stored directly on the tag. This is an example of an engine plant, one of the many customers we've had for this particular high memory RFID tag. In this case, the process of building an engine has many significant steps where you're attaching different items, you're gauging apertures, you're making sure that the tolerances are met. Sometimes you're doing rework to make sure that it falls within spec. Each of those steps can be stored by the operator, by the timestamp, directly on that RFID tag. And a PLC can check that tag at each station to make sure that the previous step has been done correctly, to make sure that this part is in the right place, and can again timestamp its operation so you get a complete record. For quality, this kind of birth history and as-built record is essential in understanding exactly how the product was built, if there was a recall or a safety issue related to that critical device. So high memory RFID tags play a really important role on the plant floor in storing operational data directly on the asset. It travels with the asset and doesn't depend on any kind of lookup or bringing any kind of information from a database somewhere remotely. Another application that we've done quite a lot of and that are talked about a lot are tools and tool tracking. We can talk about tools as hand tools, which of course is an important, there's a lot of maintenance of tool cribs and being able to take tools in and out and check them in and out. You may not have thought that UHF RFID tags could have the kind of range and performance they do today on tools. But with small ceramics and very innovative fiberglass structures that are now put and embedded directly in the tags, you can get 5, 6, 8, 10 feet of read range on a tag that is mounted directly on your wrench or on your screwdriver. Those kinds of read ranges allow you to create a virtual tool crib that will automatically allow you to check tools in and out and know where they are. The other advantage of that kind of read range of UHF is if you're in a mission-critical industry like aerospace and you want to sweep the assembly when you're complete to make sure no tools were left behind. Some people think about this in medical as well. You have the ability then to scan for those tools and make sure they all got off the job. That is more than possible. It's actually implemented in several customer sites, and we're seeing great success with that. Another thing you can do, of course, is embed these tags directly into large production tools, stamping tools, molding tools. You can record in the tags or record up in your database again the usage of the tool, when it's worn out, when it needs to be reconditioned, when it should be swapped, and keep those key parameters in. That's very, very handy for librarying these off and being able to find them in the tool stock, in the tool shed. So here we're talking about large production stamping tools, but some of the same principles apply as the hand tools we talked about. An interesting aspect for us has been some of the attachables. I'll call them attachable tags. You see a picture in the top right-hand corner. Bolt tags or hitch pin tags are very similar. The bolt tag that you see on the top left is a threaded bolt that you literally thread right into a hole in some assembly. Maybe it's on an engine, maybe it's on the frame of a car. That bolt has in its head an RFID chip, and that means you can both identify it, but again, also store key data. Understand how that engine has been tuned, understand what its maintenance cycle is, where it's destined. Does it need to be on the 4 o'clock truck? Where is it supposed to be delivered? All that information can be stored or at least looked up by the ID of the tag that's within that bolt. The bolt tends to be used by some of our customers that are more permanently attaching that bolt onto the assembly. The hitch pin tag you see on the top right is a ball detented style where you can have a worker depress the plunger and stick that plunger directly into an aperture. Maybe it's a hole that's going to be used for transporting or for hanging that part at some other part of the assembly. But in the production cycle, you can use it as a traveler, and it will travel with that part, and you can record all the same information. It's kind of a cool application, and it allows you then at the end of the line to have a bucket or a box where you drop these hitch pins in, and you wheel them back around to the front of the assembly, and you reuse those tags over and over again going through your process. In both cases, you achieve as-built records, you achieve birth histories, you achieve the ability to do QA and quality all the way through, identifying your parts directly without increasing any of your cost of your parts or shipping those tags outside of your 4 walls. Another application that we've enjoyed doing has been some of the high heat applications. Again, trying to expand your thoughts about what's possible. In the past, you may not have thought that you could have a high temperature tag that could survive your paint shop, for instance. But today, again, with a lot of ceramic tags in particular, we have an ability to do repetitive cycles at 225, 250 degrees Celsius. Certainly enough for any paint rooms that we have in most of the industrial marketplace, or for other high heat applications on tools or on different parts. These high heat tags can be covered over, they can survive overspray, they can survive pretty difficult environments in terms of shock and vibe. So if you were thinking before that you couldn't actually put some kind of label because you're used to thinking of RFID as a paper-based label, don't think that way. RFIDs come a long way past paper labels, and you can certainly put high heat tags now in almost any application that you'd like, whether it's a high heat label or whether it's a high heat ceramic wafer or tag, as we show here. And we've done a lot of those applications already. We certainly started our presentation talking about containers, and there's no question that containers are a big focus. Managing those containers on the supply chain is a separate application. We won't spend as much time today. We could do a whole webinar on managing your containers through cross-docks and through your supply chain logistics, but we'll leave that to another time. On the plant floor, you still have a significant issue getting it from the dock to line side. How do you bring those containers in and get them to the right place? How do you sequence them? So you might want to manage a FIFO process. How do you manage your line side flow racks and do replenishment on them with parts calls? Again, tags for every RTI are available, no matter what the size is, the range you're looking for, whether it's on metal, off metal, on liquid, in an aperture, temporary or permanent. There's many, many different tags that can do that. And again, the systems for RTI management in terms of antennas being located are very mature. A good integration partner, like some of those that are on the webinar today, or working with Omni-ID or some of our authorized partners, we can put together a system to manage your RTIs very, very effectively and very reliably. Probably will surprise you on how accurate and how automatic that system would be. But it's a big application we do a lot of today, and it's certainly becoming common on the factory floor. Finished goods is an area that more and more is becoming important to our customers. So we're doing what's called source tagging where those tags are embedded at the manufacturing site and they carry on into the rest of your dealer network or into your end customer. Sometimes that finished good tagging is just for your convenience, managing your finished goods in the yard and doing inventory tracking, even just for the delivery site. Some of the pictures here really talk about that. A car yard's a great example. We do a number of windshield labels or tags that can go directly onto a car or onto a washing machine. We've done placards like that for motors and large valves. Here again, being able to track your finished goods and know where they are so they can be picked up and delivered effectively can save you a lot of money and improve your accuracy. We did an application at a train yard where the finished goods are being loaded onto the train, and being able to know that they're on the right train, and not just on the right train, but that they're in the right sequence, because that train will stop and do a whistle-stop tour of several towns, and having to rearrange your inventory because they weren't stacked in right to deliver to a particular dealer or a particular location can be very expensive. So automatically reading those tags as things are loaded, making sure your sequence is right, your pack out is right, can save you a lot of money for very little cost. These tags are very cost-effective, and the infrastructure is very simple. So for inventory tracking, yard management, there's many good solutions. We show in the bottom right-hand corner an active tag. Sometimes when you're talking about yard inventory, you're talking about very large distances. You may have a set of cars spread out all over a giant lot, and using an active tag is a very good option. Don't be frightened about that. They're very stable. They have a great performance history, very, very long range, that you'll be able to scan your whole yard and take your inventories in real time and see the movement. So again, don't pigeonhole yourself into thinking of one particular technology. There's lots of ways to manage your yard today and do finished good inventory. And we spend a lot of time with that. I want to shift focus a little bit from the tracking. What we just talked about were applications where we're putting tags on really for tracking, but we're not yet broaching that topic of control. How do we actually change and control in real time the process? This concept can be thought of in different ways, but increasingly the conversation is turning to IoT, or Internet of Things. The fact that our devices are becoming smart, that very, very small, reliable chipsets are available to be able to be embedded into different products and even into some parts, into containers of parts, makes a very different conversation start. What if your materials themselves could be smart? What if they could tell you and tell your workers where they have to go next? Put me on the 4 o'clock truck. Paint me blue. Take me to line side rack 42. That kind of intelligence, or that Internet of Things capability of communicating between machines and humans, is pervasive across our lives right now. A good example here is your smartphone or your GPS. Can you imagine driving in your car and all you could do would be to see the map, but it couldn't tell you anything, and you couldn't punch your route in and have it calculate your route for you? And if you decide to turn off and to make a stop somewhere because you had to, and it wouldn't recalculate for you, how useful would that device be? And yet that's what we're living with in many of our implementations today of simple RFID or barcodes. Simply tracking, seeing what's happened, not actually altering what is happening with real-time information or communication. So collecting data is important, but a true IoT solution counts on communication between devices and humans to optimize the process in real time and be dynamic. What we're looking for today is a factory GPS. We're looking for smart materials that can actually calculate their routes, know where they're supposed to be, and if something happens, a machine goes down, a delivery is delayed, a new demand trigger comes, that we can recalculate in real time and then run our process. It's essential, and it's what the best manufacturers are doing today. We're talking about moving from simple track and trace to process control. The keys to that, as this graphic shows you, is that you need a visual element. Studies forever, certainly since the 70s when we revolutionized manufacturing according to the Toyota methods and some of the lean methods that were brought in place, found that by far the most effective way to trigger workers in a process is through visual stimulus, whether it's lights, whether it's screens, whether it's paper labels that tell them exactly the printed productions, Kanban cards. Visual cues are the most effective way for us to teach people what they're supposed to do. We all learn visually more than anything else. So I think it's key that there's a visual element to this. The second is it must be dynamic. I mentioned before some of the changes in the world that are happening today. I sit with some top executives at large manufacturers around the world, and I ask them what their vision is, what they're moving towards. And it's amazing as they talk about their customers sitting with a smartphone on their couch, ordering a new car, and deciding they want it to be this color, with this trim package, with this hitch package, and pressing buy. Their vision is that they want that buy signal to go directly to a factory and that car to be built that very day when that button is pressed through the Internet of Things. That dynamic nature that they're trying to get optimum efficiencies and customer satisfaction. And then they want the customer able to see their car being built and watch it being delivered through the process. We all on the phone are experiencing that in our lives. We shop on Amazon now and expect that package to be delivered. We expect real-time updates. We expect any exceptions to be sent to us automatically on our smart devices. Factories haven't got there yet. They're going to have to get there. And paper can't keep up. Paper can't do this. We have to adopt IoT technologies all the way into the plant walls so that the Internet of Things that people are getting used to in their lives as consumers can come all the way down to the place where their products are built. Otherwise, we're inherently building inefficiencies in the process. So many of our leading manufacturers are spending a lot of time with us, and I'm sure with others, talking about how do they bring IoT technologies onto the plant floor to make their demand more dynamic and their manufacturing process more dynamic. That inherently means wireless. If you would like to have a life-changing experience, you should visit Amazon's sortation facility and see the way that they fulfill orders today. Rather than moving the people around, they move their shelves around, they move their products around on a continuous dance of robotic fulfillment that is amazing to watch. And it's reconfigured every single minute of every single day. There is no set line or plant floor as we traditionally think about it. And increasingly, we're seeing our customers moving things around and optimizing the process almost continuously. It's not like it used to be that you're going to build this part on the same line for 10 years and everything fixed and welded and bolted into place. Things are moving around and changing, and hence wireless is becoming more and more important. Mobile workers need mobile lines and mobile flow of material, and that's important. And then, of course, intelligence. We talk about IoT. Without some intelligence in the system to guide it, you can't get to the goal you need to go. So one concept is one that I wanted to introduce to people if they're not familiar with it, is something we're doing in Omni-ID, which is called visual tagging. We're not the only ones now doing this, but we're certainly pushing this forward and leading in the marketplace with the concept. This is the concept of taking standard RFID, which is inside these tags, and adding e-paper screens to the tag. Here you get the best of both worlds. You have track and trace through RFID because you can read these tags through standard RFID readers, but now you can put visual cues right on the tag, instructions, work orders, so that the operator can actually see what they're supposed to do even as the tag is being tracked and traced through the process. Think of it like a GPS system for your material. Your material now can say, I'm supposed to be here, take me over there. I'm recalculating because I'm understanding now that I won't make it in time to the heat oven. Visual tagging fills that gap of communication in the process where you can now use RFID for track and trace, but you can communicate through the visual cues of e-paper. And various sizes are certainly available for that. And there's different formats continually being innovated both by us and, again, some other competitors who have joined this move in pushing forward on visual tagging. In our system called ProVIEW, which stands for Process View, visual tagging allows us to view the process in real time. There's, of course, software up above as well. As you think about implementing any of these systems, whether it's RFID or visual tagging, it's required that you have some material flow management software that helps you create workflows for your workers and create material flow through your plant floor. ProVIEW today has various modules within it. Think of it like a Microsoft Office suite where you might have some different things that you do, replenishment being a key feature, work instructions, and of course enterprise asset management or the track and trace we've talked about, and some additional things in WIP and supply chain that we won't spend as much time talking about today on this webinar. So I'd love to show you some examples, as I did before on the track and trace on tagging, of these visual tagging type applications. First example comes from Daimler, where they have been using visual tagging to be able to do replenishment. This is a very typical application that we see in factories all over the world where you'll have parts calls, and the parts call has to be delivered to the line side operator who called for it. You see in the picture on the bottom right an operator pushing a button on a visual tag. The nice thing about a visual tag is that you also have an operator actuated button. Someone can push it physically that trigger can also come through an RFID scan. So if that parts shelf was RFID enabled, or if it was being pulled through a portal, you could also trigger it and make a parts call based on that as well. Or if a container was, for instance, empty and was pushed down an empty shelf and there was an antenna, you could trigger that way as well. But in their case, they actually rely on the operator button push. Pushing the button makes a parts call back on the system for a pick to happen and be delivered. The nice thing about the visual tag is it allows you to reconfigure this anytime you want to. In other words, I could be calling for one part today, but I could reconfigure my shelves, and right away the new part number and maybe a picture of the part would show up on that little screen. And that means I'm calling for a different part tomorrow. I might have one of these visual tags on a shelf that has 10 different parts on it, and I could cycle through and call for one of the 10 parts. So you have a lot more intelligence because of that visual cue. The second thing that happens when I push the button is it gives me a message saying that my parts call has been made. That means I won't keep pushing the button. I realize that my call's been made and someone is about to act on it. When the pick starts to happen, I could get a message, as in this case they ask for that screen to change to say your part has been picked and it's about to be delivered. And I can give a time expectation. 5 minutes, you're going to receive your parts. This is much more in line again with that IoT world we talked about. This particular process in Daimler, they used to put a small flag up, like a golf flag, and hope that someone would see the flag and come and replenish and bring some parts. With the new parts call system, they not only get visibility, but their workers get more intelligence about what's happening in the process. And we can track that parts flow all the way from the call through the pick and through the delivery. So it's a good example of how things are changing using IoT principles for a common application. Another common application are work instructions. Most of you on the phone, if you're working in a factory, will have some concept of a build sheet or a build book or a job sheet that's going to travel with your goods. I know a plant I used to manage, we had a traveler that went in every bin when we were doing some overmolded assemblies, and the operator would pull that sheet out of the bin and have a look at what had to be done and set the machine accordingly. These travelers, while very, very common, are not particularly efficient. They're not easy to track. They certainly cost a lot of money in terms of printing that paper every day with the printers and the printer maintenance and the placement of that paper. So we worked with a company called Detroit Diesel who had a very extensive build book. They had several pages of instructions on how to assemble engines. And assembling those engines, they'd be ripping off these sheets of paper and putting them into recycling bins all the way along the line. These build books were expensive to print. They weren't very flexible to changes. There were certain places in the process where quality inspectors would gauge the material and say, oh, we need to change this. And they'd write all over the build books with markers, big black markers, and put new instructions on. None of those were captured. And again, none of the as-built records would be captured. What really happened on that line would be a mystery that was forever in some recycling bin on a piece of paper. So putting a visual tag allowed us to display those without the cost of paper, creating instant savings and ROI for the project. But more importantly, it created flexibility that those work instructions could be changed directly. We had a large manufacturer that had a desire to change quality instructions, that if an O-ring didn't seat properly on inspection at the end of the line, they wanted to be able to change the instruction at station number 2, where the operator was seating that O-ring, to say specifically, place the O-ring in this particular way, double check that you've put grease under this part, and press the button to confirm you did that. That kind of interaction you can't do with paper. But that allows them to catch quality problems immediately rather than waiting until the next day and realizing they had a problem on a whole batch. They can correct things in real time. So this example at Diesel Engines was a good example of putting electronic work instructions versus paper and all the resultant efficiencies. So as the next slide shows, it works by having these electronic tags move along through the process and be scanned, giving you immediate tracking of where the part is, and then changing the instruction based on the station. So when I get to the paint shop, I receive a code from my RFID system telling me I'm in the paint shop, and so I put the paint shop instructions up. Paint me blue. If it has to be pulled aside for QA, QA can electronically sign it and either say they've inspected it and passed it, or put new work instructions on that electronic device to say, no, it has to be reworked, and has to be reworked in this way, and insert it back into the process. All of that history can be captured on the tag or in the database up top in software. So there's tremendous savings and efficiency to quality in electronic work instructions and tracking and tracing. We talked about replenishment. Again, thinking about that replenishment and some of the basic steps, I won't go into a ton more details. I'm getting close to the end of the time that I wanted to spend with you here. But think about a replenishment cycle now where the operator gets real-time feedback on their order, just like you expect in your life when you make an online order. So it should be in the factory. That if someone's calling for parts or calling for a tool or calling for service on a machine, that they should get real-time feedback that, yes, it's happening, and I can count on that and go about my job expecting in 5 minutes for the tech to show up or for my parts to show up. And on the other side, that the material that's flowing through the warehouse is now smart and has an awareness of where it's supposed to be and what's supposed to happen to it. That smartness means that anyone walking past that bin or that container, the container can say to it, I'm not supposed to be here. I should be over there. Or I'm late. I was supposed to have been delivered 5 minutes ago. The increase in efficiency, very similar to what we found in the 70s with Kanban or putting signboards or billboards up, means that anyone is empowered to act, because that IoT principle of the smart container telling it what it needs to do, combined with an operator-readable signal, creates an ability for everyone to act efficiently in a process and be dynamic. Okay, so to conclude, again, I hope that these concepts have stimulated some thought for you. You really can improve your process. And I speak as a former plant manager myself, having gone through many performance initiatives, trying to improve process and do continuous improvement. Using RFID today for simple track and trace is an absolute no-brainer. The tags are so inexpensive. They fit almost every environment you can think of, on metal, high heat, curved surfaces. There's nothing that can't be tagged today. And if you're really trying to do an improvement project to do track and trace to improve that, you really should have a look at UHF RFID specifically and all of the options that are there for tagging things and putting systems in place to do that. It has many, many advantages. But secondly, I also encourage you to think about where this market is going in manufacturing. IoT technologies are here. They're present in our everyday lives, from ordering the soap for our washing machines to managing our cars and the things that we drive on the roads. Those technologies have to penetrate your plant walls. And you need to start looking at dynamic visual systems that allow you to respond to real-time demand triggers that are coming in from your customers all over the world and from your logistics partners who are delivering material to your docks. IoT technologies can help you with your process control, really taking a step change, an exponential change in your efficiencies and your ability to react to demand. So again, thank you for your time today. I'll turn it back to you, Mark.
Okay, Ed, thanks very much. We only have time for a couple of questions. High temperature tags, what is the typical read range?
That's a great question. We have read ranges everywhere from 2 to 3 feet out to as much as 15 to 18 feet.
Okay. Can the Omni-ID high temperature tags be read at high temperatures, or would you have to do the read when the tags cool down?
Yes, they can be read at high temperatures.
Okay. How many cycles at 225 degrees Celsius is a tag able to pass through?
Well, our quality metric is that they all must pass 100% 500 cycles, aggressively cycling directly from lowest temperature to highest temperature on an immediate thermocline. The reality is most applications don't do that kind of cycling that fast, and in practice they can survive several thousand cycles. But our guaranteed minimum is the most aggressive cycling curve, 500 times.
Okay. Do you have to have line of sight when tags are mounted on tools, and how would you handle tools in a toolbox?
Great question, and that's a misconception a lot of people have. Most of our tool-type tags, when we design them to go onto those tools, they actually use the tool as an antenna. And that means that even if it's flipped over, for instance, like you're thinking about a wrench that might be flipped over, you'll get a good read because that wave is actually being propagated through the metal of the tool itself. So we've got great experience doing tool cribs with all sorts of shapes of tools, and we've had high reliability no matter what orientation the tool is in. You don't have to read from the front of the tool.
Okay. What would be the best solution for last mile traceability for a shipping company that uses different carriers? Is there a solution yet?
Last mile traceability when you're using different carriers. So some of the, now that's a really good question. I talked about some temporary tags that we have, like that hitch pin tag that can be popped on. There's certainly labels that can be popped on and off that are very inexpensive, on metal labels as well as off metal labels that could work. So for last mile, I mean, we've done tethered tags that are hanging on straps. We've done magnetic tags where you pop them on with magnets and pull them off again. The hitch pins and bolt tags like we've talked about. So I would assume we're going to talk about some kind of temporary attach and reattach, and any of those would be good strategies.
Right. Okay, last question. Can tags withstand temperatures as high as 700 degrees Fahrenheit?
That's a great question. Yeah, I think that there are tags that can do that. We don't offer anything quite that high, but there are some specialty companies that I think are working through packages like that.
Okay. Ed, thanks very much for taking the time to present today, and we thank Omni-ID for your sponsorship of this event.
You're welcome.